So now the next thing is you're going to be given two figures, and you have to decide, are they similar? If so, you need to write a statement of similarity and also give the scale factor. Okay, so I'm going to draw two shapes. So this is called determining similarity. Okay, so how we do this. Step number one, first thing you want to do is, so step number one, okay, if you're talking, I'm going to invite you to come up and teach this. Because it means that you already know how to do it because you don't have to listen to me. Because I would like to sit down and I would like to talk to some of you while you're up here teaching. If you think you understand this already, come on up. I'll be happy to go sit and play on Facebook. All right, so the first step is to identify the congruent angles. Now, how do we find the congruent angles here? What tells us that the angles are congruent? Raise your hand if you think you know. Jonathan. What? Exactly. You're going to match up the lines in the angle. So give me a pair of congruent angles, Jonathan. Angle L and angle what? Alright, so angle L is congruent to angle V. Good. Riley? Did you just raise your hand? What? Sure. So angle K is congruent to angle U. What I do suggest you do is make sure that you keep all the angles of your figure on the same side of the congruency symbol. In other words, we started with the angles on this figure. Keep all those angles on the left side of the congruency figure. Okay, so what else do we have? We got L, we got K, we got Bill, M and W. So angle M is congruent to angle W. Good. Tyler. T and J, or J and T. And then angle J is congruent to angle T. Now, does anybody know why we need to bother to do that? There's a reason. Does anyone think they know what that reason might be? Riley?
So you know the angle pairs.
Not the angle pairs. But we can really, if we're just looking at this, we can see, oh yeah, okay, this is a right angle, angle K, and angle U is at a right angle. So we know that those two angles go together. But if we want to know similarity, what are we really want to focus on to determine similarity? Is it the angles? It's the sides. So why is matching up the angles important when we're trying to figure out whether the sides are proportional? That's really the question. What do you think? Nobody thinks anything? I'm saying, what is the point of going through this exercise?
To identify the angles.
But we don't even, do we really need to write them down? Can't we just look at it and say,
It should be first.
can't we just look at it and say, okay, this angle has one line, this angle has one line, they must be the same?
I mean, it's not that simple, because we'll get into it.
Because why?
I figure we'll get into it. You're about to tell us about it, right?
I am about to tell you about it, but I want to see if you can tell me about it first. I want to see who's thinking out there.
I'm thinking this way.
You are, so what are you thinking?
I'm thinking because sometimes the polygons are not the same.
So what is the, how is the angle? That's true. So how is writing down the angles going to help us?
So you would know when corresponding.
Not angles,
Size.
sides. Did everybody hear that?
Yes.
Sit right next to
So you did hear him or you did not hear him? Okay, so what did he say?
you. He said that the corresponding sides is why we write down the angles.
That's right. We're not really interested in the angles so much as we're interested in seeing that the sides are not identical. We don't want identical sides. We want what?
Corresponding sides.
Not corresponding.
Similar.
Not congruent.
Similar.
When you say similar, what's the word I'm looking for that starts with a P?
Proportional.
Proportional. Exactly. We want to know if the sides are proportional. So this will tell us what side on this figure goes with this, what side on this figure. Okay, is everybody following me? All right, so now, let's do that. Alan, pick a side from this figure, and then tell me what's the side that goes with it on this figure. I don't care which figure, which side you pick. Pick a side, any side. Not the length, give me the letters. What? K? K is an angle. Give me a side. Side has two letters. KL. Okay, so KL. So step 2 is to write your similarity ratio. So KL, and what side? So KL goes from the right angle to the angle with 3 bars. So what side on this figure goes with KL? UV, that's right. And now what you're going to do is you're going to write the numbers that are associated with those two sides. So KL is 24, and UV is 16. So what is the scale factor? No, don't flip it. Simplify it. How do I simplify this? Divide by 8. So 24 divided by 8 is 3 over 2. Okay, so that's the scale factor we're looking for. So what we need is when we compare the 3 other sides, all 4 sides have to be in the same ratio, 3 to 2. So if we find a pair of sides that's not 3 to 2, we can then say that these polygons are not similar. And as soon as we find one that's not, we can stop. So as long as we keep finding 3 to 2, we keep going. If we find one that's not 3 to 2, we can stop. Yes, sir. All right, so let's pick another side. Let's get another volunteer. Anna, thank you for volunteering.
You're welcome.
Pick another side, please. So this figure. corresponds to JK? TU. And how long is TU? 6. And what is 12 divided by 6 simplified? So you can,
Oh. 12 divided by 6?
well, I want a fraction. 2 over 1.
Wait, divided by 3, you get 3, right?
No.
Oh wait, that's 4.
So, look what I have. I have one pair of sides is in the ratio of 3 to 2. Another pair of sides is in the ratio of 2 to 1. That means I now know that these two figures are not similar. I do not have to keep going. But why would you? Don't. Don't waste your time. Okay. All right. Does anybody have any questions? Yes? You have a question? Question, Sandra? Dylan, you have a question? Okay. All right. So I'm gonna draw another pair of figures, and then you're going to do the same exercise.
I'm not gonna, it's not
What's the clip?
What? You don't have to draw it now. Okay. So excuse me, up here please. What did we learn?
They're similar
That they are similar. How did you know they're similar, Micaiah?
because we do the work.
Can you explain a little further, please? What did you do first?
I figured out what the angles.
Okay, so what are they?
BC equals BF.
So those are sides.
Yeah, that's how.
So I want you to do angles first.
Oh,
So angle A is congruent to what angle? E.
E.
Good. And angle B is congruent to which angle?
E.
And then angle C is congruent to angle F. Okay, now what did you do?
I put BC equals BF.
Well, not that it's equal to,
Or
but you're going to put BC over E.
Over
Thank
E.
you, Tyler. So BC is how long, Micaiah?
it is 16 over
16 over
20.
20, which reduces to what?
4 over 5.
4 over 5. Good. So now, excuse me, too loud. Keep going, Micaiah.
And then BA over
BA over
ED.
ED?
Yeah.
Okay.
Or FD.
FD. Okay, so BA is
12.
12, FD
15.
15, which reduces to
4 over 5.
4 over 5. We got to keep going. So the last pair is
AC and DF. Or yeah, DF.
D like doggy. Okay, so AC is 8 and DF 10, which reduces to 4 over 5. Very good, Micaiah. All right, so that is how you are to do that problem. Remember, it's only when you find two that are different that you can stop. Just because you find the first two pairs of sides similar doesn't mean you can conclude that they're similar. You have to look at that third side. Is there a what? No. Okay. All right, so okay. Okay, so we are told that ABCD is similar to EFGD. What we want to know is what is X? All right. So this is a very typical problem like what you'd see on the ESC, where you're going to be given kind of a figure in a figure and told that they're similar. So what you might want to do is separate the figures and redraw them so that they are side by side. So we're going to draw the little one. So this is going to be D, E, F, and G. So DE is 6, EF is Y, and this is X. And then the big one, DA, BC. So this is 5, this is 7.5, and this is 9. Folks, you getting this down? Okay, does anybody have any questions about what I've done so far? Gentlemen, I separated the shapes. I separated the shapes so that I can more easily see which side goes with which. Because I'm already told that they are similar. So when I go to make my proportion, it's easier for me to see which side goes with which side. So, I'm given, I know that X has to be, I want to know what X is, so I know that X has to be in my proportion. Okay? So, I'm going to put X now. This is very important. This is a place that students make mistakes all the time. And that's when they're setting up their proportions, they don't stay consistent. And what I mean by that is you mix up which part goes where. So what I recommend is wherever you put the X, make sure you label. So we're going to call this one the little figure and this one the big figure. So you're going to put the little figure on the top and the big figure at the bottom. Because when you set up your proportion, you have to be consistent. It's got to be little over big and then little over big. If you put little over big and then big over little, you're going to get the wrong answer. Yes, sir?
I got ratios mixed up with proportions.
Well, the ratio
Ratio
is
like
1.
we used last time, like that was an extended ratio. But there was no conception of a new or big.
Well,
But
because
the proportions there is, so one is two different things.
a ratio is one comparison. A proportion is two comparisons. Two ratios put together that equal each other. That's a proportion. If I just have one, I don't have a proportion. I only have a ratio. So what value goes with x? 7.5. Because remember, I'm already told that these are similar. So this side, so FG goes with BC. All right, so now I have to pick another side. Well, the problem is this is a variable. I don't want to pick the variable, so I'm going to pick 6. So 6 goes with what? 9. Now I have a proportion. I have two ratios, and I know that they equal each other. That makes a proportion. So now all I have to do is cross multiply. So I get 9x is equal to 7.5 times 6, which is 45. So to solve for x, I'm going to divide both sides by 9 to get that x is equal to 5. Go on. Okay, I do have two quick vocabulary terms for you.
Bro, I don't even know what we're talking about. I know, we're trying to complicate, bro. What? No, they just... When we're trying to do a map,
I'm talking about races.
Okay, so a scale drawing is simply can anyone give me an example of where you might see a scale drawing? Blueprints? Blueprints for a building? No.
It's a painting.
It's a painting of a person. Where else do you see scale drawings?
Like model music theory and algebra.
What did you say? But a model would be an example of where you would use scale. I want to know scale drawing. No. Okay, the one I was going for is a map.
Oh, that works.
So a scale drawing basically, look, if we want to have a map of Sarasota County, obviously we're not going to have a full-size map of Sarasota County.
Why not?
Sarasota County is 50 miles long and 20 miles wide. So instead we have a scale drawing. When it says on the map, each inch is equal to 5 miles, that's the scale. The scale is the ratio that compares the length in the drawing to the actual length. So if you have a blueprint and it says 1 inch equals 1 foot, that's the scale. The blueprint is the scale drawing. Sometimes on a map it's called the legend or the key, but that indicator that tells you that 3 inches on the map or 3 inches on the blueprint is equal to some number of feet or some number of miles, that's the scale. Okay? So, how do we use that? So, I have in the book a picture of the Golden Gate Bridge. And on the picture of the Golden Gate Bridge, it says that the scale is that 1 centimeter is equal to 200 meters. Okay, so what I'm told in the drawing is that if you've seen pictures of the Golden Gate Bridge, it's got the 2 spans in the middle of the bridge. And it tells me that on the drawing, the span is 6.4 centimeters. What I want to know is, what is the actual length between the spans? That's what I want to know. Okay? So, what we need to do is what? How are we going to solve this problem? Bill? Fractions to do what? We're going to make a proportion. Okay? Now, again, my suggestion is to do little over big. Okay? And I even write it down so that I don't forget. In this case, little is going to be the drawing, and big is going to be the actual bridge. So, what do we know? Somebody else. What do we know? Larry, what do we know? That's right. So we know that 1 centimeter is equal to 200 meters. Okay? What else do we know? We know that the span where? The actual span? We know on the drawing the span is 6.4. So what are we going to use to represent this? X. In the book you'll see it use S, but it's X. Now we have a proportion. So to solve this proportion, we're going to cross multiply. Very good. So now this is nice and easy. Because look what happens. I get 1 times X gives me X is equal to 200 times 6.4. I simply plug that into my calculator, and I get 1,280. This is the most important part of the problem. 1,280 what?
Meters.
Meters.
Can you use the calculator much faster?
Yes. But you have to understand how to set it up. But yeah, of course you can use a calculator. Did you have a question? Did someone say where did the 6.4 come from?
No, I was just asking if that was thought it was a 64.
Ah, 6.4. Okay. Does anybody have any questions about this use of scale drawings? Does anybody have any questions about anything that we covered today?